Hey everyone, welcome to today's video around fractions larger than one. This is a pretty exciting piece. There's nothing new that what's going on. We already know fractions. We can make sense of what we know about fractions. But up until this moment, all of our fractions have been less than one, right? We've been talking about maybe something like 3/4 or 3/4 or 3 divided by 4, which is technically telling us that according to my denominator, my model would be cut into 4 pieces, and my numerator would tell me that 3 of those are shaded. Now, technically speaking, this whole bar here was the representation of 1, and we can see that 3 of the 4 pieces that make 1 are what we have. Therefore, we have something smaller than 1 because here's 1 right here. So that's kind of what we've been looking at. We've even looked at that on number lines. We're again realizing, oh, well, it's smaller than 1. So my number line only goes to 1 and it's cut into 4 pieces. And each piece has this label to it. And 1 itself is 4/4. So here's 3/4. And that's smaller because, well, 1 would be 4/4 or all of it. So that's kind of where our history has been with fractions. What we're going to start talking about is like, well, fractions actually do get bigger than 1. And what does that look like? How do we represent that as a number line? How do we represent that as fractional parts? And then like, how do we make sense of it? Like, what does it mean to us? So let's kind of dive in and play along with that journey as we look at, again, fractions larger than 1. Dun, dun, dun. Dun, dun. I had to make the music longer because I was still writing. So fractions longer than 1. Wait, larger than 1. Longer? What? Oh my gosh. Larger. Fractions larger than 1. Let's get to it. So let's just think about how we would know this. We can actually understand that a fraction is going to be larger than 1 just visually when we see it. So here's an example of a fraction that would be larger than 1. We have 5/2. Now, why we know that is larger than 1 is because our numerator is larger than the denominator. Again, remember, these are those terms we've been using. Numerator, that is the top number of the fraction, and then our denominator, that is the bottom number. So we already know this is larger than 1 because my numerator is larger than the denominator. So that's the first thing that sticks out to us. Now, what does this really mean, right? What is the representation of this now? Because how do we put this into context and say, oh, that's larger than 1, and what does it look like? And this makes sense to me. Well, as you know, as we are always talking, the denominator is your best friend. We said that day one. We keep saying that. We're all about that. The denominator is your best friend. So if you pay attention to the denominator, it really tells you what's going on with your work. If we focus on our denominator here, what it says is our whole is 2 pieces. That's what that means. So if I just started with a fractional part, right, like we did, I'm going to take a rectangle and I'm going to partition it. Well, I have to follow what the denominator says. And again, my denominator says 2. So I'm actually going to take this whole and cut it into 2 pieces. Okay. And then what we do is we shade in how many we see as our numerator. Well, if I go up here and look at my numerator, I have 5. Okay, cool. Let's go down here and start shading in 5. So here's 1, 2, 2. Wait, what? 2. Wait, I've only done 2. So then you start thinking, oh, well, how can I shade in 5 pieces if I actually only have 2 to shade in? Well, haha, that's why this is larger than 1. Because remember, this model represents the number 1. And that number 1 is cut into 2 pieces. But we actually need 5 of these pieces. Well, right now, I only have 2 of them. I only have 1, 2 pieces, and I need 5. So in order to do that, I actually can draw a second hole. So I'm going to draw a second hole, right? This is still the number 1, but at this point, that's 1 plus 1. So we kind of have 2. And again, the denominator says, well, it's cut into 2 pieces. So I'm going to partition it into 2 pieces, and I'm going to go back and shade. Haha. So 1, 2, 3, 4. Now I shaded. Oh, wait. Actually, still have to shade in 5, but I've only shaded in 4 so far. Oh man. Okay, I thought I had this. So yes, we've gotten larger than one, but we've even gotten larger than one itself. These fractions are actually even bigger than that because I've done 2 models, but that's only 4 pieces. So guess what? I'm going to do another model. Unfortunately, because I didn't plan this well, I'm going to draw the model this way. Nothing like changing things up to be confusing when you're learning something new. So at this point, again, here's the number 1. And I'm going to cut that into 2 pieces because that's what the denominator says, right? Denominator is your best friend. Denominator doesn't change. So the number of pieces I cut my hole into doesn't change. And then I'm going to go ahead and go back and shade. I need 5 of these. Okay, cool. 1, 2, 3, 4, 5. Oh, I did it. I did it. I did it. We did it. So this is actually a representation of 5/2 or 5 halves or 5 out of 2. I actually end up seeing that I have 1 hole, a second hole, and then 1/2 of another. So this 5/2 is actually the same. Oh, this is going to get messy. Let's put this over here. So this 5/2 is actually the same thing as 2 holes and 1/2 left over, because that's what this says. And we can actually look at that mathematically. We've already done that. We actually know this in division. This is what gets me so excited about all this stuff is we already know that, right? Like, let's go over here and look at that idea. If I have 5/2, well, we know that this actually says the same thing as 5 divided by 2. We studied that in class. So if we actually did that division problem, well, let's see. 2 times 2 is 4. I have 1 left over, therefore I have a remainder. This would be the whole number quotient. So if I had something like 5 divided by 2, it would actually say I have 2 and 1/2. 2 and 1 out of 2 left over. Well, isn't that what we just did here? 1, 2, and 1/2, or 2 holes and 1/2. So this is pretty cool that like things that we were doing earlier in the year tie back into this. This is why we talked about writing our remainders in division as fraction or fractional parts, because this is where they connect it. Okay, so that's a ton of information at once. I know, I do that all the time. I get so excited. It's a lot of information. Let's just go back and keep playing with this idea of fractions larger than 1. So I'm gonna move on. Let's just pick another fraction. What if we said 4/3? Okay. Step 1, I know this fraction is larger than 1 because my numerator is larger than the denominator. Step 2, well, what would this look like? Well, I'm gonna model it first. So I'm gonna take my whole, and the denominator says I gotta cut it into 3 pieces. The numerator says I need 4 of these pieces. Right? It says I need 4. Well, here's 1, 2, 3. So I don't have enough yet. So I'm going to go ahead and make a second hole. Again, it needs to be cut into 3 pieces. And then here's my 4th piece. So I could shade that in. So 1, 2, 3, 4. And what I see from this, what I see is that 4/3 is actually the same thing as, well, this is 1 hole because I have all of it. So it's the same thing as 1 hole. And, well, what this says here is 1/3, right? There's 3 pieces. I have 1. So this 4/3 is the same thing as 1 hole and 1/3, or 1/3. So again, I have a fraction that's larger than 1. It actually got bigger than 1. Now we're going to stay with 4/3 because now let's look at that on a number line. So now we have 4/3, and we're going to look at that on the number line. Cool. Well, one thing I know about my fractions is they're going to be smaller than 1. So I'm going to go ahead and take my number line and put it to 1. I'm going to look at my denominator, and it says it's out of 3. So I'm going to make 3 pieces. I'm going to label my parts. Super important. So 0/3 is here. This is 1/3, 2/3, and 3/3. Nailed it. Oh, wait, I didn't nail it because we're actually looking for 4/3. And if I look at my number line, 4 out of 3 actually doesn't even fit on here because here's 3 out of 3. And 4 out of 3 would actually come after this, right? Because we can count fractions that way all we want. 0 out of 3, 1 out of 3, 2 out of 3, 4 out of 3. Oh, wait, 3 out of 3, 4 out of 3, 5 out of 3, 6 out of 3, right? Each time I'm just adding one more third, I'd go on forever. 7 out of 3, 8 out of 3. This would go on forever. And if we look at this, we actually don't have room for 4 out of 3 on this number line. So my number line didn't work. Well, that's okay. Happens all the time in math. Let's just get rid of it and start over. That happens all the time in math. Erase it, start over. That's okay. That's like part of learning. That's what I love. So let's go back to this and think, oh, well, what happened? Well, I actually had to get bigger than 1. So my number line is actually going to go bigger than 1. So this time I'm actually going to put my number line to 2. And I know that 1's right in the middle. Now here's the tricky part about a number line is, again, I got to think about that denominator. Well, the denominator says 3, and that's what each whole number is cut into. So I actually have to cut this into 3. So again, I'd have 0 out of 3 here, 1 out of 3, 2 out of 3, and this would be 3 out of 3. And then I'm also going to cut this whole, right, which is the number 1, and the number 2, I guess is the way to think about it. It's the number 2. I'm going to cut that into 3 parts. So if this was 3 out of 3, well, this would be 4 out of 3. This would be 5 out of 3, and this would be 6 out of 3, which, you know, I can't resist to talk about this. That is 2. Because 6 divided by 3 equals 2. And remember, that's what that symbol means. It means we're dividing. So that makes sense. So if I look, oh, well, 4 out of 3, well, that's right here. And again, if this is 1, that's bigger than 1. So here's what we understand about fractions as they get bigger than 1, right? Is that 4 out of 3, again, it's the same thing as 1 whole, right? Because I had all of this. And then 1 more third. So that's kind of cool. I think it's cool. You're maybe still scratching your head and saying, well, I don't know about this, and that's okay. Let's just do one more. And then again, you always know it's all about practice. It's all about time in class. It's all about asking questions. So don't worry, but let's just do another one. Let's go with halves. That's good, right? What did we do the first time? That was 4 out of 3. Oh, we did halves. Like, I was so excited. Let's do halves. We've already done that. Okay. How about we do fourths? Okay. And maybe this time we do 7 out of 4. So 7/4 or 7 out of 4. Okay, again, I know this is larger than 1. I knew that because the numerator is larger than the denominator. That's like new news to me. Extra, extra, read all about it. The numerators are bigger than the denominators. It's big news. Again, that just means I have a fraction larger than 1. It's still a fraction, it's still parts, but then what does it look like? So let's model this first. So first things first, let's do a fractional part. Again, my denominator says I got to cut this part into 4 pieces. But the numerator tells me I need 7 of these pieces that are this big. Well, there's 1 of them. There's 2. There's 3. There's 4. Well, that's 1 so far, 1 whole. But I still need more pieces because I need 7, and right now I only have 4. So I'm going to go and I'm going to make a second model. Again, the denominator doesn't change, so I'm still going to cut this into 4 pieces. And let's see, we had 1, 2, 3, 4, 5, 6, 7. Okay, I'm done. I pull that one up, so it's not a whole. But now I can think about what this means. So if I have 7 out of 4, well, this, but it also means I had 1 whole. And, well, let's just read what this says. There's 4 pieces and 3 are shaded. Oh, and 3 are shaded in. So I have 1 whole and 3 out of 4. Okay, so that's where we're kind of at with this. I do understand that this can be challenging, so I do not want you to feel, I want you to be able to practice and ask questions and kind of make sense of this, and know that again, it's all about exploration. You're gonna have times like here where maybe you make a number line, it's not big enough, so you have to erase it. Maybe you have to really step back and model and really think, what am I looking at? But also hold on, that we understand, right? We understand right away if that numerator is larger than the denominator, which is new news to us, then we have a fraction that's larger than one. So I'm going to keep us at that so that this doesn't go on too long. And again, continue to keep asking questions, continue to be active. Do not feel discouraged. Math is all about exploration. You ask questions till things make sense, and you continue to do trial and error till you get there. So keep up the great work. We appreciate you, and we will catch you next time.